This lesson can't take less than 20 minutes. It's just not possible to do it justice and make sure that you guys are taught correctly and make it just go really fast. So bear with me. Today is 9/7. And today, tomorrow, probably Monday, for a few days of class here, we're going to be working on one really big, kind of specific but big idea, and that is absolute value inequalities. This first 7 or 8 minutes of this lesson is designed to get you to have, hopefully get your head around why we're doing what we're doing, why we write things certain ways. And so first, let's just conceptually make sure you understand the main idea. If I told you that I'm thinking of a number X, and all I'm willing to tell you is that his absolute value is bigger than 4. What could X be? X cannot be 3 because the absolute value of 3 is 3, and 3 is not bigger than 4. I agree with this, although it's not the be-all, end-all final answer. X does indeed have the right to be anything bigger than 4. 4.01, 5, 629 million. Anything bigger than 4 makes this true, but I think Tommy's going to bail us out. What else could be true? And don't even say 5. I want to go back again and say, does 4.0001 work? Yes, so we're not talking whole numbers here. Literally any number, the smallest amount imaginable to the right of the number 4 is a solution. And Tommy said something that I think Adam wants to sort of elaborate on. So we've got this huge set of solutions that are over here to the right of 4. But there's another batch where anything less than -4, correct. So what starts to happen here is, and this I think will come to light if you have no idea what we're talking about right now. If we take a look at the number line, let's allow ourselves to see what's going on. Here in the center of the number line lies 0. Now, if I say to you, I need you to pick a number that's further than 4 steps away from 0, then you could head over here to 4, stick a boundary there, make sure it's hollow, because 4 isn't greater than 4, right? But anything to the right of 4 is a solution. But teamwork provided us with some good information here. Not only are those numbers to the right of 4 satisfactorily more than 4 units away from 0, there's an entirely infinitely large set of them over here as well. As long as my distance from 0 is greater than 4, then I've solved this inequality. So far, so good. From this point on, this is what you'll hear me. It's a very casual term. I just started using it like, I don't remember when. I just will call this a splitter. It's what it feels like to me, is I feel like it's splitting itself this way and this way. And I want you to kind of understand that there's a radius. I sometimes use the term blast radius. Like imagine a bomb goes off at 0 and, it puts off 4 miles worth of radioactive funk. You see then that you've got this area of 4 miles where all the bad stuff is, where no one can live, but then outside of 4 is where you can. Now, what I want you to help me with is we're going to complete this first puzzle, and we're going to convert this white graph now into a compound inequality. Compound inequalities are what you took a quiz on last week. All the stuff with ors and ands and all that, those are compound. Could you write the white graph as a compound inequality for me? I'll take it if anyone wants to say it. You can't write it like this. I appreciate the sentiment so much more than you know. But this is not the kind that you can write as number is less than X is less than number. That will only work when the numbers are squished from goalpost to goalpost.
Yeah. Okay, so it would be X is less than -4.
Say it. No.
Or.
Always or with a split like this.
4 and X is greater than 4.
What we have up here on the board now is our introduction to the next week of our lives. We have all three pieces now of the puzzle. We have what's called an absolute value inequality. We have it converted into a compound inequality, and then we have the graphical representation of the compound inequality. I really, really hope that that sort of together makes some modicum of sense to you at this point. Why that works the way it does, why the graph looks the way it does. If it does, let's change it now. This time I'm thinking of a number x whose absolute value is less than 4. This changes the game. Because now, rather than like a bomb going off and spitting out all this radioactive funk, this time you can think of it like as a bomb goes off, but instead it like attracts particles magnetically and it has a strength of 4 miles. So it's collecting things and pulling them in to within this radius, and then all the stuff out there doesn't get affected. This is the worst analogy I've ever come up with, but you get the idea that the points are being collected inwards, not forced outwards, right? So when we talk about like what numbers would work, if I wouldn't do this, but if I went around the room and said, okay, everybody give me a number, you could be like 2, -1, 0, 3.1, 1.6. Like we could do this all day. But what we would figure out is that every number that we say is within a walking distance of 4 from 0. And so let's put a graphical representation on this. Here's my number line. As always with these base examples, I will put 0 dead center. That's where the bomb goes off. And then I've got my boundaries at -4 and +4. I will again have open boundaries, not that it matters. If you haven't figured this out by now, the whole open circle, closed circle thing is, generally speaking, just a very small detail, right? So in this case, they're open, whoop-de-doo. And where will my shading go? In between. So this time, and there's no going outside and outside. I can't leave the confines of my walking distance of 4. I hit the wall over here at negative, hit the wall over here at positive. So the shading in your notes should look like this. And now I'm going to ask you to put a compound, this is your moment, Brickard, a compound inequality representation to the situation. I'm ready.
-4 is less than X less than 4.
Top notch. Good on you, sir. That was perfect. Someone earlier said, wouldn't this be the kind where I could write and? And I was like, yeah, that's a good question. Yes, but no. Remember, we want our inequalities to be as nice and pretty and compact as possible. So what Adam is saying there is, yes, X is greater than -4 and X is less than +4. But this is the time when we are encouraged to condense it into that tight little conjunction package. Okay. There are 2 more examples I want to talk about, and then we'll encapsulate all the information and then get off and running on some real examples. So here's another one. I'm thinking of a number x, and his absolute value is less than -1. I would like you guys to give me some possible numbers as I pour some coffee here. I'll take what you got. Rickard? Yes. And I'd be really honored and thrilled if every one of you could agree that it has to be no solution. What is the lowest? Absolute value is like a machine. You feed it a number X and then it churns it up and it machines it up. And then it, like any good machine, produces something, right? It does something. And when an absolute value returns a number to you, what's the very lowest number it's ever going to give you? Ever. 0. Like that's not a Mr. Ahern thing. That is a fact. Absolute value cannot go greater or go less than 0. So by definition, it sure as heck can't go less than -1. If you see a problem like this, you may stop. No solution. Done. What would the graph of that one look like? Just empty, right? And lastly, thinking of a number, x. his absolute value is greater than negative 52. And we want to say it could be, we're going to use that inf word, but we're not going to say infinitely many. We're going to say all real numbers would work. I would offer you everything that I have. I mean, I shouldn't do this, but I would offer you everything that I own if you could find me a number that doesn't solve this problem. And I'll give you the rest of a human lifetime to do it. Try as hard as you want. Put in the most obnoxiously negative number that you want, negative 1 million. I'll show this guy what happens when you take its absolute value. It flips positive. No matter how hard you try, this particular problem solves itself. So our solution here is all real numbers. And the graph of this one would, of course, be a number line entirely shaded with big old chunky arrows on the ends to really make a point. So right now, I'm going to construct something with you that I know, I didn't used to do this, but year after year, I get a little more nervous about this lesson. I know right now that the next 3 or 4 minutes are critical. I'm going to prepare with you a box that you're going to put in your notes so that you can refer. This is going to be your one-stop shopping box as it all starts to kind of come together. So here it goes. If you have an absolute value of whatever, and it's greater than a positive number, go back and I refer you back to the very first example from 9 minutes ago. What happened when we had absolute value of something is greater than like 4? It goes opposites. We made boundaries. We set one at -4. We set one at 4 and said, adios, never to be seen again. And so this we're going to come to know, at least I refer to it as a splitter. So when you hear me use that term, I would expect that maybe you'd want to use it in return. Splitter is when we think, oh, that's the less than this or greater than this situation. Let's say I get an absolute value of whatever, don't care, and it's less than a positive number. What's this going to be? You'll remember this from our second example. This is now our saying we're going into each other, and my name for this, which use it if you want, don't care, I call these squishers. So we're squishing inwards when that walking distance is less than a number. We're splitting outwards when the walking distance has to be greater than a certain number. That leaves us then with 2 more possibilities, and here comes one of them. What if the absolute value is greater than a negative number? It's going to be all real numbers, because all absolute values are greater than every negative number in the world. Finally, what if the absolute value of whatever is less than a negative number? There is no solution. Listen, other than instances where zeros come into play, if that happens to come up, we'll discuss that if the time comes. These are the 4 instances. I want you to put a big box around this, and I want you to understand that you're probably going to be coming back and looking at this several times over the next few days. This, again, is your little one-stop shopping cheat sheet for where do I go from here. Okay? Having said that, let's begin. I've got a handful of examples. If all of that made any decent amount of sense, you're going to crush these. No troubles. Here's our first example. The absolute value of x over 3 is greater than 2. You remember that I think yesterday I told you guys, oh, it's so important. You got to get the absolute value by itself. That's a big one today too. It obviously doesn't apply to this problem because it's already by itself, but it's going to come into play soon. So for now, yes, the absolute value is by itself. This is the crossroads. This is the point in the problem where you now look back at that box and say, you're one of these 4. Is it a splitter, a squisher, a no solution, or an all reals? Definitely a splitter. Because it says the absolute value of, don't really care, is greater than +2. Now, would anyone like to try, without a graph this time, to construct the splitter, the disjunction inequality? Go ahead, Ember. It's -2 and 2 are what you're looking for. Don't, as far as you're concerned, that doesn't exist. I really need you to promise me that you will not look inside those. Okay? Don't do that. What's inside is of no interest yet. Until we can convert it into the land of compound, don't touch it. Aiden, you look like you were ready to say something. You want to try? I need a compound inequality for this. Picture it right now, if you will. Picture, you don't have to close your eyes, but picture a number line and picture -2 and the graph going to the left. Nice. And then picture +2 and the graph going to the right. Just the fact that that image can come into your mind, that will tell you how to build the math problem that we have to solve. I'll do the first one. Whatever's inside of the absolute value must maybe be less than -2. That's where I create my first force, where I walk over 2 steps to -2 and say, go that way. That's the nature of a splitter, is you say, get less than the negative. Now, the other side of it is I want to walk 2 steps to the right and say, go that way. Go to the right of the positive. I need a really important word here. It's important. Anyone want to take a stab at the right-hand side? Adam? Yes. That right there is the moment of truth. That's the moment at which we turn it from something that is not solvable into something that is mathematically workable and solvable. We don't solve absolute value inequalities. We convert them to compound and then solve them from there. And of course, to solve these, you know this because you've already aced a quiz on it, we're going to multiply both sides by 3, and we're going to get x is less than -6. And on the other one, we're going to multiply by 3, and we're going to get x is greater than +6. There is no better way to write a disjunction like this. There's no we're not going to shortcut it. We're not going to pack it into one little cute thing. This is how a disjunction is presented when it splits, as these all will, for the record. Now we got to make a graph to complete the trifecta. Absolute value, converted to compound, solved. Let's make a graph. What do I need on my number line? Not in this case. I had 0 because I was trying to teach you the idea of that blast radius, that distance from 0. I don't need them anymore. Who do I need? Yes. -6 is a must. +6 is a must. That's it. That's what I need. Now I'm going to make some boundaries. They're going to be open. And where is my shading going to go? Outwards, yes. So that is a completed project, example number 1 in the books. Absolute value, convert it to compound, do your thing, graph it up. Good. We learned this earlier today. The young lady in second hour was not making her absolute value bars tall enough, and at one point mistook one of them for a 1, and it caused a whole problem to have to be redone. So make sure that you make them tall enough that they're clearly not 1s. Just a pro tip. Just thoughts in general as you look at this problem. I know it's hot and it's hard to come up with clever things, but just what is your first thought when you look at this problem? It's probably going to be a squisher. I will, however, tell you, as you'll learn for the rest of this lesson, what looks like a squisher won't always stay a squisher. Can you think of what I might mean by that? If what was a negative? If that freaking 3 were a negative and I had to divide by it to get the absolute value by itself, then what would happen to my sign? What looks like a squisher might often become a splitter and vice versa. So don't pass judgment. I appreciate the sentiment, but it's too early. So what do we do before we press on? Get the, not the X by itself. You get the absolute value by itself. Again, don't even pay any mind to what's in there. It matters not. You want to get the bars alone. Don't add 10. Don't move. Just get rid of the 3. And how do we get rid of the 3? So yes, we have the absolute value of x minus 10 is still less than or equal to 12 divided by 3. Really important. And we math teachers, we like to think that we're always saying important things. This is important. You got to get every problem to this point. This is the crossroads. It should be on your paper. I shouldn't have to try to read your mind. Every time I come and look at one of your problems, I should say, there it is. She got right to the crossroads. This is the point when the absolute value is by itself that you go back and look at your notes and say, you're one of 4 things now. You either split, squish, no solution, all real numbers. You're one of those 4. Who's this one? It's going to be a squisher because it's less than a positive number. Again, the or equal to matters very little in the context of what we're doing. So does anyone boldly want to try to write a squisher? I haven't asked you to do this ever before. Well, what we're going to do right now is we're going to convert it from its current absolute value format into what we call a compound inequality, and then we'll get x by itself. Adam's diving in. Go.
Where the negative 4 is less than the absolute value of, oh no, it'd be x minus 10, then less than or equal to 4.
Yeah. So I'm going to walk you through this again because I want to teach you how to, without fail, ever write a squisher. This is writing a squisher 101. This is for the mathematically anxious who kind of panic a little bit. Here it goes. So here are the steps. I'd love to think that that makes perfect sense to you, that you got negative 4 is less than this. And so it's like all between and stuff. But realistically, we just got to know how to do it for now. So here it goes. You see this number over here, 4. Make a copy of him on the left, but make it negative. And then make a copy of him on the right and keep it the same. This will always work. And then the cream filling in here, this x minus 10, take off his absolute value and stick it right in the middle like this. And then duplicate the Pac-Man and you're done. So it's a less than. We wouldn't be having this conversation if it weren't. It's a less than, so I'm going to duplicate it here and here, and voila, that's your squisher. This is an and problem, but we know better than to write and. How are we going to solve it now? Let's finish. We're going to add 10 to all 3 sides. And when we add 10 to all 3 sides, we wind up with our solution, which will say 6 is less than or equal to x is less than or equal to 14. Let's graph this mambo jambo. What do I need on my number line? That's it. That's all I need. 6, 14. Don't make cute little tick marks or scale things out with a ruler. Just stick them in there, man. That's all we need. What are my boundaries going to be? Closed. Good. Where will my shading go? Yes. And that is execution of a squisher. Get it alone, convert it, solve it, graph it. Any questions? Next one. If your first instinct is to look at this and say, that's a squisher, then you're about to learn why I said what I said about don't pass judgment until you're at the crossroads. You're not at the crossroads until it says absolute value and nothing else. So I don't know for the life of me why people answer this question oddly, but just think algebra, basic 8th grade algebra. What's our first step? -5. Listen, I always go back to this example over here. If I said to you, solve this equation, I'm not even going to ask because I know for a fact that not a one of you in this room would hesitate to go subtract 5 and then divide by -2. The rules of how we solve equations don't change just because we're doing something fancier. I still want to move the 5 first because it's the plus or minus. It's the backwards order of operations thinking. So 5 is out. I leave the -2 times the absolute value of 4 minus x. And I have is less than 45 minus 5, which is 40. We're still thinking maybe this is a squisher. What do we have to do now? We have to divide by -2. And when we divide by -2, we better have our thinking caps on. We have the absolute value of still don't care what's in there is what? Greater than what? The whole dynamic of this problem just got flipped on its head. Suddenly we realize, oh boy, not only is it not a squisher, this is one of those two weird ones from my notes. So I go back and I think about it and I say, okay, I know I'm done. I don't have to do any math in this problem. I just got to know who's who. If it says absolute value is bigger than a negative, what is the answer? The answer then is all real numbers. And if you were to graph it, you would just shade the whole number line. You come to really appreciate that at the end because you get kind of, whether it's tired of doing it or scared of it, there comes a point where that feels like a little miniature vacation. Like, yeah, nice. Saved me 5 minutes. Next one. -10 minus the absolute value of -2x plus 5 is greater than 3. We know better than to pass any judgment as to who this is because we're not at the crossroads. So basic algebra, what happens first? Subtract that 10. So what's left is negative absolute value of still don't care is greater than 3 minus 10 is -7. So maybe this is one that's shaping up to be one of the weird ones. But we don't have the right to judge it yet. The absolute value is not by itself. What do we have to do? No. We have to divide both sides by that stupid -1 that you can't see. You just see the negative in front of the absolute value. And like any good equation solver, you're not going to stop until what you wanted to get alone is alone. And when I divide both sides by a negative, I get the absolute value of still don't care is less than what? And just like that, if that were a test and you had called it as no solution or something, you lose a ton of points because you never even get to the point where you get to turn the key and unlock the math problem. And then you realize it's a squisher. Who wants to write my squisher? Anna, you want to help me? I'm terrible at this. I'm ready. Absolutely beautiful, Anna. Thank you so much. That was perfect. That's how you write a dang squisher right there. Negative is less than cream filling is less than positive every time, just like that. Now we got to do a little basic algebra. What do we do to solve this bad boy? Let's subtract 5 from all three sides. So we wind up with -12 is less than -2x is less than 2. And what do we do next? Yes, on all three sides. You're going to wind up switching 5 signs. We're going to go, ready? Switch, 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 switch. That's the beauty of dividing by a negative, is that everything gets jacked upside down. So here it goes. When I divide by -2, what do I get on the left? Yep. And this Pac-Man whoop, whoop, reverses. Switch again. Still great. Everything switches. And what becomes of the 2 on the right? Becomes -1. 2 divided by -2 is -1. Now, this answer, if you turn it in and you put a box around it, I will count it correct. I'm just here to tell you, I'm not supposed to teach this into you. It's unhealthy, but I want you to hate this answer. It's not wrong, but why would a guy like me hate this answer? Because it's bass-ackwards, right? Think about it. This doesn't match the number line, does it? Is that what you're going to say? I don't like that it's backwards. And so I personally, you don't have to. Every time I get to the end of one of these switchy squishers, I'm going to switch it again, just for cosmetic purposes. So it will, when I reverse it, say -1 is less than X is less than 6. I love this answer way more. This switch of signs from here to here was mathematical. This switch of signs is cosmetic, appearance only, right? I'm going to pause this real quick. I think I can. You are screen sharing. Resume recording. We're back. 2 more examples. I thought that would get us to the end of the finish line here. So here we go. Let's finish. We got this. 4 times the absolute value of 6 minus X minus 12 is less than 20. And quite frankly, we will finish this one. This one has a little funk at the end. I forgot. So what are we going to do first? Yeah, and then what? Right? We shall pass no judgment about splitter, squisher, all reals, none of that until we've got it isolated. So adding 12 produces this. Dividing by 4 produces this. And there's the crossroads. What is it? Squisher. Jose, you want to help me write this squisher? I'm ready. This is negative less than cream filling less than positive. Squisher. That's how we do it. You're going to be so good at that. If you're not already, you're going to be masterful in about 24, 25 hours. You'll be like, perfect, I got this. And there is my squisher. You cannot solve absolute value inequalities. You can convert them and then solve that. Now I can solve what Jose gave us. So what are we going to do first? Subtract that positive 6 away. You get -14 is still less than negative X is still less than 8 minus 6 is 2. And we should hate this answer too, because it's not done. What do we have to do? Switch everything because there's a negative on the X. If you want to be all mathy proper, you could say we're going to divide everything by -1. But in reality, you're just going switch, 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 switch. So I'm going to wind up with positive 14 is greater than positive X is greater than, switch the 2. And as I said on the last example, this last part is up to you whether you flip it or not. I can tell you this. If you elect to not switch it cosmetically to put the negative on the left, and I ever see you do this, then you and I are going to have a very long, serious talk about where your head is at. Has it happened before? Yep. And that's why maybe I get a little leery of certain things. So I would encourage you flip it. -2 is less than x is less than 14, and then your graph will, of course, match up from there. Last problem, and then it's work time. Say again. Yeah, no backwards number lines. That's no good. This will conclude your notes for today. At the end of this problem, we'll pack them up. We'll try to knock out a couple problems of our Delta math, and that'll be that. Tomorrow will be a full work day. 55. I'll only get in your way if there's a real need or like if you ask a question. So let's do it. What goes first? Yes. Leaving me with the -3, still leached onto my absolute value. Still is greater than 29. -5 is. What do we do now? Yeah, watch out. We just divided by a negative number. The stuff inside the absolute value doesn't give a hoot. But what's the last part going to say? I need more than that. Is less than -8. And then you're like, woohoo, it's one of these. This just saved me like 4 minutes. Thanks. Appreciate it. This would have no solution because, as we discussed, once you're at the crossroads, absolute value by itself, I look. And if the number over there is a negative, it's either going to be no solution or all real numbers. And this one is, of course, ain't happening. No solution. Good. Stop screen share.